All right, ladies and gentlemen, we're coming back at you again. This is section 8.6, coming from Math 1050 Wayne State University. Again, my name is Rush Mahaber, and I will be taking you on a beautiful path down quadratics yet again. Now, we've done just about everything we can do with these things, quadratic functions, right? Degree twos, we've talked about how to solve them, how we are supposed to approach them, how to graph them. Okay, to some extent, we have not gone down though. Okay, so we're going to go down that path now, and that's what we're going to talk about today. In section 8.6 is graphing quadratics. Now, anytime you encounter anything that's weird, okay, we got to first start off by just trying to introduce ourselves to that thing, okay? So, this is no different. Graphing is always the same. Always the same. Unless you have some familiarity with the type of graph. And what I mean by it's always the same is if you don't know what it looks like, you plot points. That's all it is. You just plot points. There's no ifs, ands, or buts about it. If you don't know what it looks like, you just plot points. And eventually, you'll end up doing it. That's kind of what happened. I don't know if you guys remember when you guys were in like elementary school, they had you guys plot a whole bunch of points, hopefully. At least they did for me. And then they said connect those dots, and then it was like some picture or something that was there. Well, that was kind of graphing in a sense, right? So just plot points. If you don't know what it looks like, just follow the details on the map, and then you connect the stars, and you can see the constellations. All right. So anyhow, so that's what we're gonna do. Now, all quadratics come from the king or granddaddy or the originator, the basic quadratic graph. Okay. So what I mean by all quadratics, so all quadratics, which look like ax squared plus bx plus c if we were trying to graph these functions, okay? So they look like this, okay? All of them come from the basic quadratic. The most basic quadratic, and that is this guy. The most basic quadratic, and I'll write him in black because we're going to work with him quite a bit, is f of x equals x squared. And again, we know about functions. We know how to put stuffs in and get things out, and that, domain range. So remember, all the things with functions, we must know again to apply it as we move forward, okay? So how are we going to do this? Well, again, we're just going to plot points. In order to do that, we just make a t-chart. Okay, so I'm just going to t-chart x and f of x, okay? And again, be well-rounded, plot some negatives, some positives, right? 0 when possible, okay? You don't want to break any domain restrictions, though. Okay, so here we go. So I'm going to plot -2, -1, 0, 1, and 2. Okay, so when I plug these in, and we're going to do some mental math here, okay? So, again, we're going to plug -2 into our function, and then the thing that should come out, all of you should give me the answer, and the answer is go. You guys are correct. You said 4, right? And then same thing, plug in -1, go. The answer, when you plug it in, -1 squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared clearly is 4. So you're going to get, and remember, these are just the points. Okay, I always draw terrible graphs. I have to work on this. All right, so there's our graph, right? Here is the x-axis. Here is the y-axis, okay? So we just need to plot these. So here's a -2, 1, 2, 3, 4. If you don't have the ability to graph on graph paper or anything like that, make sure your hatch marks are close to being equally spaced. If they're not, you're going to distort your graph. And something that's supposed to look like a horseshoe shaped or a squiggly line will end up looking straight because you kind of stretched it out a bit. Okay, so be conscious of it. Okay, 0, 0, 1, 1, and then 2, 4. So the daddy of all quadratics is this beautiful creature. Oh, I didn't even go through the points. Let me try to connect the dots again, guys. All right. And got it. All right, so that's the daddy of all quadratics, known as this degree 2, and he has a special name. He's called a parabola. Okay, so parabolas are no big deals. They're all horseshoe shaped. So all parabolas, bolas are horseshoe shaped. Okay, so I don't care what kind of degree 2. For example, if it was f of x equals x squared plus 3x plus 5, right? And I said graph that guy, I can already tell you he's going to be horseshoe shaped. The question is, I don't know if he's going to be up in the sky over here on the graph, if he's going to be down here, or if he's going to be over there, right? So, but it will be horseshoe shaped, which is moved around. So we just have to figure out how it moves, and we're ready to rock and roll. But the bottom line is all degree 2s look horseshoe shaped. And that's all that matters. All right, so now that we got that down, okay, let's go ahead and do some stuff with it. All right, so what do you need to know? So now we know that all degree 2s are horseshoe shaped. Well, let's look at a couple of things. Okay, so for example, okay, and I'm going to try to do this very orderly. All quadratics, okay, have a very special point. Okay, so here's one. I'm just going to draw it. I'm not going to give you the equation for it. I'm just drawing it. Okay, the topmost point, or maximum, or quote unquote the bottommost point, and I'm just drawing this randomly. There's no particular rhyme or reason behind these couple graphs. Okay, one more graph. Why not? Let's do one of these. I think we did one of those, didn't we? How about this? Let's do one of these. Oh, we did one of those too. Ah, how about that? There we go. All right, this. Okay. Now, why am I highlighting those points? Okay, so I'm trying to make a point about those points. So these 3 points here, okay, the top or bottommost point, the turning point, if you will, has a very, very special name. Those red points are called the vertices, okay, or vertex. Okay, so the vertex is either the max / min of a parabola. And the reason why I said slash is because if it's upside down, parabola. If it's upside down, okay, it's going to be a maximum point, right? If it's right side up, it's going to be a minimum point. So you have to pick and choose depending on whether or not it's upside down or right side up. But we'll talk about that yet again some more. So that's all we need to know, is this is how these guys looked. And these are called vertices. So these vertices can be points. So this one can be like -2, comma, oh, can't be -2. I'm going to call that 2, sorry. 2, comma 3. And call this one, I don't know. Well, it looks like 3 to me. And it looks like -3. So I'll call this 3, -3. And we'll call this -4. Boom, 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 boom. 6. Okay, we'll call those the points of my vertices. Okay, very, very simple. Okay, now, there is also something we're also interested in. Okay, and that thing that we're also interested in is what's called the axis of symmetry. It's the place where if you were to slice this particular graph, if you were to put a line, like pretend you were a ninja, and you were to slice it, where could you fold the 2 halves over completely, one on top of each other, and you couldn't see one from the other? Well, turns out that place happens when you do a vertical slice through the vertex. So when you do one of these. So this is called the axis of symmetry. Okay, so only if I sliced it that way would I be able to fold the left side of the graph onto the right side of the graph. So the axis of symmetry is the place, I guess, the place you fold the graph. You could fold the graph. Could fold the graph. Fold. I promise you I can spell. Only on Tuesdays though. Fold. You got me off by 4 days. The graph on itself completely. Okay, so that's here. And remember, it's going to be the equation of a vertical line. So it's going to be x equals something. So it'll be, in this case, sorry guys, it'll be x equals 2. This case, it'll be x equals 3 again. The x equals 3. And this is x equals -4. So we're pulling on those skills we learned back in chapter 2. Okay, so you got to be very conscious of this. All right. So, things we've learned. We've learned that all quadratics look like a horseshoe shape, okay? Whether it's going up or down, we just got to know how it's going, okay? That's the first thing. Second thing we learned is that every quadratic has a vertex, which is a maximum point if it's like this, or if it's a minimum point if it's opening upward, okay? Very, very cool. And then finally, through that point, you have an axis of symmetry, which is going to be the equation of x equal. Not y equal, not z equal, not just the number. It has to be x equals, okay? That gives you that vertical line. All right. So when we come back, we'll talk a little bit about what changes the graphs and what transforms it and what makes it move around and do all those good things. All right, guys, so watch the next video. All right. Catch you on the flip side.